Hey, everybody, and welcome to another Into the Terminal. Today, we're going to be talking about the built-in automation in RHEL and Red Hat distros. So normally when we talk about automation, we're like, oh, shell scripts, blah, blah, blah. No, but today we're going to be talking about Ansible and specifically Ansible system roles.
I mean, we like shell scripts. Shell scripts are fun,
I mean, we do like shell scripts, clearly,
but not
because we
today.
talk about them a lot. Yes, but not
Yeah,
today.
not today.
Why don't we jump into the terminal and I'll show you one of these in action.
That is a great idea. Here we go.
So the idea is that we're going to write some description of how we want our system configured, and then we're going to run an Ansible playbook, which will go out and execute those configurations against one or more machines. And so today, just to get started, I'm going to be running on one machine. But later on the episode, Nate's going to do some examples running across a bunch of boxes. And we'll talk more about what systems roles are and how they work and some of the design philosophy behind them in a little bit. But to get us started, I've made this very simple playbook. And this is for my standard operating environment, right? Which is why I called it an SOE. We're going to run this on the list of hosts, localhost. If we're connecting to remote systems, we would be using root to like execute stuff on the remote systems, because a lot of these system roles are actually making configuration changes to the machine. So things like if you were configuring new network adapters or network interfaces, that's a root thing. Here in this one, I'm tweaking a proc setting. That's a root thing. Or enabling session recording withtlog. That's a root thing. All right, so in the variables section, we describe like what it is we want to change about this machine. And then in the roles section, this is where we identify what system roles we're using in this playbook, which determines what variables we can put in the vars field. All right, so to get us started, Nate, SE Linux, everybody's favorite.
Make sure that's turned on, man. Don't turn that off.
Yeah, well, guess what? Oh no, on this box, it's turned off.
Shameful.
It is. And maybe we want to make sure that on every system that we have in our network, we want this to be enforcing. So we're going to add a little bit to our standard operating environment playbook to make sure that that's the case. All right, so the first thing I'm going to do is I'm going to go down here to the bottom, and I'm going to put in a listing for a new role. Oops, role. So there's an SE Linux system role. And now that we're referencing this new role, we can then start to add variables in the var section that leverage the properties and capabilities of this role. So I'm going to come over here and I'm going to put in SE Linux state enforcing. And then I'm just going to run the playbook again. Somewhere in here. All right, let me just run the playbook again.
For folks that are unfamiliar with how those variables that he set versus the roles sort of interact, imagine it's sort of like, imagine the role like a pre-made script, where at the top of the script, you're setting all the variables that say what goes where, right? Except in the Ansible world, it's including that role, which is a predefined playbook of tasks, right, that carry out different things based on how those variables are set.
Yeah, and one of the design things with system roles, and one of the cool things about them, is that they're designed to work regardless of the version of the operating system you're running on. So we're running on RHEL hosts. Well, I'm running on RHEL hosts. I don't know what Nate's running on yet. We'll find out together. But my SE Linux role is updated to work on RHEL 7, 8, 9, and 10. So if there was some change into how we made sure SE Linux was enforcing in any one of those releases, the system role would account for it. And if it was running on a RHEL 10 box, it would do it the RHEL 10 way. And if it was running on the RHEL 7 box, it would do it the RHEL 7 way. So the role itself takes care of any of the differences in the distribution across versions. And that's SE Linux is pretty standard across, so that one's not super interesting. However, in a little bit later, we'll add some time server configuration, and that is very different between the versions, right? In RHEL 7, that was NTD, and in RHEL 10, that's the Crony service. And each of them has their own configuration files, and the configuration files are formatted differently. And the system role, I could just be like, this is the time server I want in the variable. And then it will take care of putting it in the right file in the back end, using the right syntax in that file in the back end to make sure that my system is configured to have this time server that I wanted without necessarily me, the administrator, needing to care about how that's implemented on a RHEL 7 versus a RHEL 10. Right. So I can use one role or one playbook and the role to go across all these different versions and be pretty confident that what I intended, which was a SE Linux setting or a time server setting, is accurately depicted on any of the supported distributions. All right, so we're finished. So it was permissive before I ran the system role. Now it's enforcing. Right? You're like, why didn't you just run set enforce and turn it to enforcing? I could have done that on this one box. But the other thing with system roles is maybe I want to make sure that all of my boxes are in enforcing, and I have 1,000 systems.
Yeah.
So I use this one system role, and then I run it, and it goes out to all 1,000 systems and make sure that all their SE Linuxes are in enforcing mode. Right.
I mean, this is the story of automation in general, right? I mean, but yeah, the cool thing is that this subset of roles is included with RHEL, and we'll talk a little bit more about that in a minute.
Right. And so like periodically, maybe I run the system role to go out and like set standard configuration parameters across a set of systems. And that way, if 3 weeks ago, somebody was troubleshooting and they turned SE Linux off to just part of their troubleshooting and they forgot to turn it back on, well, now that I'm running my playbook again, it gets turned on. Right. So it kind of like reconciles any of those weird things that happen just during the runtime and natural operations of your systems by your administrators. All right. But wait, there's more. So the SE Linux system role, like enforcing permissive. Okay. That's interesting, I guess. But did you know it can also do SE Linux policy stuffs? So for example, maybe, I want to make sure that if a server out there attaches to port 8009 for its web services, I need to account for that in my SE Linux policy set, right? So currently, let's look here, SE manage, port -L, little grep, HTTP. Oh, actually, the one I was going to do is already in there. But
pick a new one.
So, yeah, I'll
10,
pick a new one.
Or 10.
Oh,
maybe not 410.
We may get an error because it's live demo. What could possibly go wrong?
What could go wrong?
Actually, let's do 8010. That'll be all right.
Okay.
So what we want is like an additional port to fall into this list because I know that in my organization, that's something that we do. And I don't want to have to go around to each individual machine when I'm installing the web services. I just want it to be like by default configured for every machine, right? All right, so we can come in here and we go to the variables section and we can put in something that looks like this. And Nate, do you see I'm copying and pasting so that I don't have to type it all and mistype it all?
All kinds of prepared today.
I don't know what's happening.
But it won't paste? There you go.
No, it's more like me typing poorly. All right, so let's do 8010. There we go. All right. So we rerun the role. And now anybody who had their SE Linux in permissive mode, they're going to get it enforcing again. Anybody who had their swappiness set to something different will get it set to 20. Anybody who had turned off session recording will get it turned back on again, because that's part of this playbook as well. So we're just like constantly smashing down the standards every time, the same standards every time, in case there's been something that has gone
And the nice thing is here, you'll see in the output here, some of them say skip, some of them say okay, some of them say changed. The way this operates, as long as you're doing it right, because there's certain cases where this is not true, but if you're using a role and you're using it the right way, when you apply these changes, it won't redo the same change. So it's idempotent in that way. So like the change you're talking about with SE Linux, it's not going to go and tell the system to set SE Linux to enforcing again if it sees that it's already set to enforcing, as an example, right?
Yeah.
So that's also a nice feature. And again, most automation languages do it that way, but Ansible is included in that list.
So here's the message out of our output that says that we should have changed the port. So let's take a look, shall we? Oh, there it is. Woo!
There you go. 8010.
Bullet.
You thought it didn't work, huh?
I did. I was expecting it to be down there with 8009, but apparently not.
No. Must be put in the order they were added or something.
That would be my guess. Similarly, maybe you have put things in a weird place, right? The number one rule of SE Linux is put things where people expect them, where the policy already expects them. But some people don't like it that way. So maybe you created, when you do your web services, it goes on port 8010, already weird. And then you also create a directory called /web. And that's where all your web server content goes. So we can go ahead and configure the systems to account for that too.
Yep.
So just like we could use our playbook to add a port.
All you have to do is hire a junior admin, tell them what command to run, and have them do it on all 1,000 systems, right?
That's right. That seems like a real thing that people do.
That's my kind of automation. Tell someone else to do it.
Come on now.
Copy, paste, fail.
It's between my two boxes today. Copy. I've been having some weird, like, movement between my boxes. All right. So what this says is we're going to set some SE Linux file contexts. And specifically, in the file context setting on the machine, we're going to create a context setting for /web and anything underneath of /web. It's going to be set so that that's HTTPD syscontent T, which is the type of SE Linux context you want for web server content. File type. So you could actually make this apply to only certain kinds of files. A says any kind of file, but you could do things like say, oh, this should only be applied to directories under /web or files that are under /web. I said everything.
Right.
Yeah. So, and then we're also going to change it dynamically.
I'm a little disappointed that I still have to remember that funky syntax for the target.
Well, you know, but now you can just put in a file, and then do you really need to remember?
That's the thing I always get wrong when setting them. I always get the slash or the dot backwards.
It's dot star.
Yeah. Or is it the star and the slash? I transpose them. Anyway.
So what should come out of this is when I look at SE manage F context, we should see that that's been added to our configured file context for the machine. And again, like,
now, will that apply
this across all 1,000?
Will it apply it to the directory, or do you then have to run a restore con?
You would then need to do a restore con.
Okay. Which you could also automate.
Yeah, but like what we're trying to do is I know that when I stand up web servers, they attach to port 8010, and I put their web content in /web.
Right.
So in my standard operating playbook, I'm going to make sure that every machine,
Sure.
8010 is a web server allowed port, and any /web content gets the right context. That way, when I stand up a new box and I apply this playbook to it, and then I install the web services on it, and then I put all the web content on it, it's already done, right? Because as part of my initial setup, I put these things in place for if it was going to be used for /web. All right, so
But if
let's
I
see.
were
Moment of truth.
applying this to existing machines, is where my question was coming from, right? So
Yes,
maybe
if
those
you're applying
existing
to
machines
existing
did
machines,
not already have SE Linux set to enforcing, and now we're enforcing it. So we're also trying to account for those contexts. You may also have to make the restore con happen, is what I'm getting at.
Yes. If you were applying this to existing boxes with existing files, you would want to also do a restore con now that it's in there. All right, so here we go. There's in my file context my setting for /web that it's now a HTTPD syscontent TTP. We can do all kinds of SE Linux things. We can do booleans. We can set booleans across all the machines. We can get really exotic, right? So like our machines are using the targeted policy. You can change the policy if you have another one, but also some policies are user-based. And so you can actually do like SE Linux user changes and context changes and like all kinds of other stuff beyond these basics, right? These are the common ones that we use for targeted policy SE Linux changes. But yeah, so there you go. You like get your thing that you want, smash it across 1,000 boxes.
Right. Cool.
So that's a little bit on like getting started with system roles and creating that playbook. Nate, why don't we talk a little bit more about like what system roles are? Like, how do you even get them?
Yeah. So, I mean, we touched on this a bit while Scott was doing his demo. I covered, and there was some chat going on. So maybe we'll actually start with. I have a machine here that I'm going to use for my demos that I have not installed the system roles on yet. Now, so I'm going to go ahead and bring up my screen share, and I'll show you how that works, because it's pretty easy, and we can talk over it while it's going here. So, just a moment. All right, so here we are. This is a pretty clean RHEL 10 box, 10.1. All I've done to it is install updates on it. And I've already got my playbooks on here, but I have not actually installed system roles. So the RHEL system roles are based on an upstream project called the Linux system roles. And they do, like Scott was mentioning earlier, how they account for many different versions of RHEL. The Linux system roles, what they're based on, count for many different distributions of Linux too. So there's a lot of cases where you may be able to run these against machines that aren't even RHEL, right? But the intention of this episode is to show you how they work on RHEL. So it does need the Ansible engine to actually execute. You could also use them with the Ansible automation platform, but we're not going to really cover that today. So to install them, it's just DNF install RHEL System Roles. And this will bring in some other required packages. Oh, I guess it doesn't. It must include, I must have already had the Ansible engine itself installed. So now we have the RHEL system roles installed. Now you would install these. You don't have to install them on every system you intend to automate against. These are things that have to exist on the machine that you're running the automations from. So in a case where you're using one machine to automate against thousands, like Scott was talking about in the initial demos, you would not need to install it on those 1,000 machines, just the one you're running the playbooks from. And of course, if you're using something like Ansible automation platform, then that already has all you need already included. But I'm just using a RHEL host here. So we're going to run the playbooks from here is where we need it.
The thing that you need is Ansible Core.
Ansible Core. That's right.
We moved away from Ansible Engine. Yes.
Yeah. Now, there was some questioning in the chat about Ansible being installed via pip or being installed from DNF. And really what Scott just mentioned there is the core difference. The one you get from pip is upstream Ansible. That's a Python thing. It's basically a Python package that you can install via pip. The one you get included with RHEL is sort of a stripped down, I shouldn't say stripped down functionality wise, but it basically comes down to things like how we can support Ansible, because the full package does a whole lot. And it's kind of a nightmare for our support engineers to be able to support all of that, right? Because we end up with questions about stuff that are just way outside of the RHEL box. So that's why it is that way. And then, of course, if you need to do like full-on enterprise level automation, that's where automation platform comes in. Go ahead.
And so what comes with RHEL is Ansible Core. Ansible Core is to support the following things: system roles that we're talking about today, remediation playbooks from OpenSCAP, and remediation playbooks from Red Hat Lightspeed, formerly known as Insights. So those are the three things that Ansible Core is going to support and work on. Can it do stuff beyond that? Maybe, but also maybe not. But we make sure that because we want those three functionalities to work out of the box for every RHEL and every user of RHEL, that's what Ansible Core is designed to support.
Right. And I have used it for one-off playbooks and stuff. The difference is what can you contact Red Hat support for and what can't you? And that's why there's a difference in the packages. Okay. So we have it installed now. I guess I might as well move into our first demo, but I've talked a lot about automation platform. Not a lot. I've touched on automation platform. So really one of the first questions I want to address is, do you need Ansible automation platform to use RHEL system roles? And the answer is no. And then, of course, the immediate follow-on question might be, do I need an additional subscription or add-on subscription for RHEL to use the RHEL system roles? And the answer to that is also no. You can run these on any system that you have entitled to run Red Hat Enterprise Linux. That includes the free developer subscriptions all the way up to the the premium subscriptions that you can buy for that extra support and extra update support and all that stuff. So if you've got RHEL, you got the RHEL system roles, period. It's really what it comes down to. Okay, so we already covered how to install them. My first demo is actually the firewall system role. So let's open that up here. I have two of them, that's why. Okay, so this is a really simple example of how the firewall system role could be used. In this case, I'm doing two things just to show you that both things are possible. One is I'm telling firewall-d to open a service based on those service definitions that firewall-d knows about. So there's this service flag here, or variable, right? So vars firewall service HTTP, and I say it's enabled. You could also tell this to close that port if you wanted to, right? You could say, I absolutely do not want HTTP enabled, and you could codify that in your settings here and say definitely don't open this port. And then, of course, the other way you'd open ports in firewall-d is not by service, but by numeric ports and the protocol that they listen on, right? So in this case, I've also got an example here that opens port 8090 TCP, and of course, I told enabled. And then there's options here, which I'm sure there are sane defaults to, but I wanted to include them just to be certain in my demo. You can say, do I want this only in runtime, or do I want it to be permanent as well? And it's nice that these are configurable, because what I could do is say, runtime false, permanent true, and then it won't take effect until the next time the machine reboots. Maybe you have a situation where that's important, and it's nice that this is configurable here, right? So of course, I'm doing runtime and permanent because I want it to take effect now, and I want it to stay in effect the next time I reboot. So there's that. And then of course, I call the role, the RHEL system roles.firewall. Now, with Ansible in general, there's a place where all of your roles are stored, and I always get it wrong when I think about it. I think it's user share Ansible, or is it user lib Ansible? But there's a roles subdirectory in there, and you'll find all these system roles in there along with documentation, right? So if you need to know how to use one of these roles, you can also ask something like the Lightspeed command line assistant, which is working pretty well. Go ahead, Scott.
Or you could RPM QLD RHEL system roles.
There you go. That'll tell you where the files are. Okay, so I've told this to run on just localhost. So we're going to go ahead and run this, and then I can show you kind of what it runs here. So first of all, I don't even have firewall D installed on this machine. I wanted to call that out, right? So firewall D is not even a service that's running on this machine at the moment. So we're going to go ahead and say, run this. And while it's running this, one of the tasks, which we may not notice as it scrolls by, but it does happen, it'll actually install and enable firewall D. So one thing you want to be sure of, if you're running this on a swath of 1,000 systems, is that you get those firewall rules right, because you could accidentally lock, yourself or even your automation. Say you're closing off the SSH port to only a given set of networks. Make sure you get that right, because Ansible runs over SSH in most cases. In fact, that's the default. So you're going to want to make sure that you don't accidentally lock yourself out of the machine, and all of a sudden all of your automations fail because you closed off port 22. But anyway, so it's installed firewall D. I think that's up here somewhere. And then, of course, it has opened up the service and the port that I asked it for. It's telling us here. Right. So now if I did that firewall CMD list all again, now we get a response from firewall D. And you can see right there, I've got services, port 8090, ports, port 8090, and services, which previously had a couple things in it, like SSH, cockpit, and DHCP, now includes HTTP. So you might say, well, firewall D wasn't installed. How can it have these things already enabled? That's because that's how it comes out of the box. Those are the default ports that are open. Maybe you want to make a rule that closes some of those. Maybe you don't want cockpit open. Maybe you want to limit who can get to cockpit. You could make a rule that says that. Any comments before I move along? Because I have a more advanced firewall example as well.
No, hit us with the more advanced firewall demo.
Okay, so I made a second playbook for this, and what this is going to do is I wanted to. There's a lot of flexibility in firewall D that some people either don't know exists or don't really leverage, and that comes in the form of zones. With a zone, you can do things like, this collection of IP addresses gets a different set of firewall rules than the public internet does, right? And so it's really good to be able to understand zones. If you don't understand them, go read about them and figure out how they work. But also that you can manage zones using this firewall system role as well. So you can see here that I've got my HTTP service still in here, but I'm adding a source to it that says things that are trying to get to HTTP have to come from 192.168.10.0/24. So that basically says that network is allowed to get to HTTP. And then I'm also adding port 1234, and I'm adding that to the zone work, right? So if I run this, what it should do is it'll add those additional ports. Now, I didn't tell it to do anything with that port 8090 from earlier. So I'm pretty sure what's going to happen is that's going to remain in my rules, because I didn't say to remove it either, right? So keep that in mind, that this is going to be additive in most cases. So let's do firewall list all, right? And you can see that 8090 is in fact still here, but the 1234 that I added is not, because I added that to a different zone. This is showing us the public zone, because that's the default one when you do list all, right? You will see that, the sources were added to the public zone, right? So that way, things that are coming from the public are going to be limited to that source. Now, I think I could have gotten more restrictive as to the IP range that I wanted with the source. Maybe that requires a rich rule. I don't remember exactly how that works with firewall D. But if we do the same thing, the list all, but we add -- zone equals work, you'll see that added to the work zone, right? See up here, it says work. We have that port 1234 that I was talking about. So
what does
you
our
can see
playbook look like?
Playbook looks like this.
All right. So one of the things I like about system roles is, like, when you're providing a rich rule, there's all kinds of stuff, and options and things that you need. Here, you can just put in a couple of things that you want to change about the firewall rule, and then that's it.
Right. So, and again, you can probably go like way off the deep end. Go look at the documentation for how this system role works, and you can get a better idea as to how granular you want to get with these things. Now, we talked before about running this stuff on thousands of hosts at a time. I did actually set up a couple extra hosts here, and I made an inventory file. So if you've never looked at an Ansible inventory before, it's basically like an INI file, if you're familiar with the INI format, right? You have these headings that then group settings. So I've got a heading here that says primary. That's the machine I'm working on right now. I've been calling it localhost because that way I don't have to actually specify any inventory. And secondary. These are my other 3 machines that I have set up, which are also clean slates at the moment. So if I wanted to take my firewall advanced rule and I wanted to change it so that it will affect all of the other machines, right? What I do is I change hosts over to secondary. And again, this is whatever you name that group of hosts. It doesn't have to be secondary. You could call it web servers. I don't care. Okay. And then there's some other changes I have to make. So I've been running these as root on my local machine. Not always the best practice. And you saw Scott earlier. He had his playbook set up to connect as the root user. In my case, I usually like to lock down SSH so that root can't access machines, and that's considered good practice. And that's if you have root locked down so that it can't connect to you can't connect to root over SSH, then you won't be able to run Ansible over the root account either. So you can either in your Ansible configuration specify what the remote user is, or you can enter one in the playbook that you're going to run. Now, it's probably better to put it in the Ansible configuration, but for the sake of today's demo, I'm just going to put it right inside of the playbook here. Remote user, Nate. I have a user on the other machines called Nate. I've already set up public key infrastructure so that I can use an SSH public key, private key, public key to connect to those machines. And then, of course, because Nate does not have permission to make any changes like set firewall rules on that other machine, I also have Nate added to the wheel group, and he's allowed to make changes without a password using sudo. So this become true will basically tell the Ansible playbook, and when it executes on the remote machine, connect as Nate, and then use sudo using the sudo rights that Nate has to become root, and then run the playbook. So we're going to go ahead, save this out. Ansible playbook. This is where we have to specify the inventory. Now, you could, again, in your Ansible configuration, say, here's my inventory file. And then when you run Ansible playbook, you don't have to tell it where the inventory is. It'll just know. But in my case, I didn't set up the configuration file. So we're going to use the inventory file that's in this directory. And then we're going to do firewall advanced. And what should happen now... Oh, I didn't. Did I get the keys moved? Maybe I didn't. Hold on. I know why it's doing that. Let me switch over to this other machine. This is the machine I tested all this on and set up all the keys on. I forgot to switch tabs. Sorry. So let me fix that up. We need to add. Change this over to secondary again. This is a separate host, by the way. Sorry about that. I forgot that I had intended to do it that way because this is where I had the SSH keys set up. Okay, remote user. I think that was the only changes I had to make. Now we'll run it here. Now it should work because here I have the keys set up and I have all of them. I already connected to them once before, so that it wouldn't be asking me to validate their host identities. So, all right, so what this should do, okay, so you can see here it checked to make sure systemd was running or installed, right? I don't know if it would have went and installed systemd. That might have been awkward.
Systemd is one of those things that kind of is on all the RHELs.
Yeah. Imagine if you were launching it against a machine that doesn't run system. I guess it would know. It's supposed to know, right? It's supposed to account for that stuff. All right. So anyway, you can see here that now instead of running all these things against a single host, it ran it against multiple hosts, and it did all of these over SSH. Remember, I didn't install the system role on all these other machines. All I did was set up SSH authentication so that when I run these things, it can SSH in, and then it executes the commands that need to be run in order to make all these changes. Now, if I were to go to one of those machines, I'd be able to show you that, in fact, it has the firewall rules added, just like this one over here did when I ran it locally. But I don't have sessions open to those, so you're going to have to trust me. All right. Do we have any questions that are around that demo? Because I can move on to my next one if... actually, yours is the next one. You've got time sync.
Yeah, mine's the next one.
Yours
Take
is the
that.
next one. Take that.
So we have all of these different things, all these different roles. And I think the big thing to take away is that it's probably impractical to memorize all of the variables and all of the settings that you might want to use in your playbook. And so just to quickly return to what Nate said about documentation, let me toggle my screen share back on. I said RPM QLD RHEL System Roles. So Nate said use a shared doc. There's a directory for each system role. And so, for example, we're going to be taking a look at the time sync system role in our next demonstration. And there is an example. Right, so like this is a playbook that you could take, and it would create these time servers on a machine that the playbook was executed against. And if you don't want 4 NTP pool or pool.ntp.org systems, you can actually like specify the host names. And there you go. You could like copy and paste. You could also take a look at that README. There's an HTML version of the README and there's a Markdown version of the README. You can take a look at the Markdown version on your using less, and that'll go through a lot of additional options that are available, right? Because there's a ton more stuff that you can set on time servers than just the host name and whether you want it to burst or not, or interval burst. So you can get documentation for all those additional components. And then oftentimes the either HTML or Markdown will also have more examples of using individual groupings. That's actually where I started with the SE Linux system roles was I wanted to change the ports, or I wanted to change the context that was assigned to the ports, but like they gave examples and I could just tweak the bits that I wanted for my specific use case, right? So you don't have to memorize all the things, right? Leverage the documentation. All right. So we want to add some time servers to our machines. So the first thing I'm going to do is I'm going to come down here and add a new role. Called time sync. And then now that I've got the role added, I can start to use the variables that are provided by that role to define how I want my time settings to look. So I used that example I just showed you and made a couple of tweaks. There we go. And let me get this formatting right, because Ansible cares about white space. It uses white space to denote indentation, or not just indentation, but like what things are related to other things.
Yeah, the number of times a good playbook fails because I missed a space is well, I'm almost ashamed to say how often that happens.
Yes, let's not. Let's pretend that never happens. Okay.
Good old YAML. Everyone loves YAML, right?
That's right. So I'm adding, essentially using the timesync NTP servers variable, and then a couple of additional configuration parameters to it. I'm going to make sure that this machine is set up to use two time servers.
Mhm.
All right, so now it's in there. We can just run our playbook. And just like Nate was saying for his example, right? Now that I added a new role and we're going through, we're going to have to test the setup of the machine that we're running the role against. So things like, is Crony installed on this machine? If not, it will be installed because you want to do time server setup and you need a time server to do time server setup. I mentioned earlier that one of the cool things about system roles is that they support multiple versions. And so as we did things like we moved from NTPD to Crony, the system role took care of checking that behind the scenes. So even in places like in RHEL 8 and 9, where we had both Crony and NTP, it would actually look to see which one was there and which one it should use for configuration. So if both were there, it would prefer Crony. But if only NTP was installed, it would do the NTP's things. And if only Crony was installed, it would do the Crony things. And if neither was installed, it would install the right one for that version, right? So
Right.
RHEL 9 installed Crony by default if you didn't have anything installed.
Sort of like mine installed firewall D. It didn't go and get like IP tables or something because it knows RHEL should have firewall D installed.
All right. So now if I run Crony C, Crony C sources.
There you go.
Right. So in my playbook, I said timeb.nis.gov and one of the random ones from the ntp.org pool. And that's what you see coming out the other side, right? I'm configured with a specific one, and I got this random one assigned from the NTP pool.
There you go. Cool. So time sync all around the world. That I remember when I was learning, I forget what it was, Puppet or Chef. It seemed like everybody's first example was set up NTP.
Well, because that's super important. Like having the right time on your machine
it's important,
is crazy
and
important.
it's pretty low stakes, right? If you're setting up a time sync server, as long as you don't totally muck that up, it's probably not going to nuke your server.
So you know who loves well time synced servers? What software loves it?
Oh,
SSL.
directory services. Oh, SSL as well. I was thinking authentication directories like either IDM or Active Directory. They love synchronized time.
Well, they love synchronized time because they're using SSL for transmitting all their data between themselves. And
right. Well, ticket exchanges as well.
Web services.
Right?
Yeah. Kerberos. Yeah.
Right.
So yeah, time is important. So
that ticket is too old. Well, it's actually not too old. It's just that you're in a different time zone than me, or time was off on my machine, right?
Well, that's the thing is, so SSL, if the time differential is more than 5 minutes, it doesn't matter if the public and private key cryptography exchanges worked and the testing was accurate. Because the time between when the public and private keys were transmitted and yada yada is more than 5 minute difference in the timestamps, it will refuse to make any connections with that box.
Right.
So time is important.
So I've got 2 more to get through, and we're almost to the end of the hour. Although we did start late, so maybe we go over. I don't know. So
we did. I have another one too, although I don't know if people really care. It's
okay.
Short.
Well, mine shouldn't take too long unless we have questions or something. But let's go ahead and get through this one. These 2.
By the way,
and
now's the time that you should ask questions. In the chat.
You should ask.
Leave us a comment.
Get all the questions. Okay, so there's 2 things that are important. I know one of them is something that I actually mentioned earlier in the episode about something that I think is important on all the machines that I set up. And then another one is very important for compliance reasons. The first one is hardening SSHD, and the other one is system logging, right? So how long do you keep your logs? Where do you keep them? Are they ephemeral or are they not, right? That sort of stuff. These can all be configured with system roles. So the first one I'm going to show you here, and you'll also notice that I'm putting these all in separate playbooks where Scott is building one big playbook. They're both correct. It all depends on how you want to run these automations, right? If you have like a modular sort of approach, which is kind of the way that I did it, versus like one big playbook, the way Scott did it, right? So you can apply more than one playbook to a host, It's just that you have to keep track of where you're running what and whether one thing will undo the other, right? Whereas if you have one big playbook, it's a little easier to keep track of all that stuff. So just keep that in mind.
Well, I mean, if you have one big playbook, also when you make a typo, you have a lot of stuff to go through to find that typo.
Right.
But I would say like don't overdo it on big playbooks.
Right.
My intention with mine was I have a standard operating environment, but then maybe database servers need something different. Or
Exactly.
maybe the systems that I do dev need something different. And so I'd basically just duplicate that thing and then tweak it for whatever environment I wanted to run against. And then I control that with something like the inventory.
Another approach could be that all of the things that are in common go in one big playbook, and then you have separate playbooks for all the things that are different.
Yes. Yeah. Or you could do modular where you actually like pull the module into your main playbook and you just like identify which additional modules you want the clients to run.
That gets harder and harder to track when you're not using some sort of an automation platform. Hint, hint. It gets a lot easier when you have something like AAP to track that stuff. Okay, so let's get back on topic. This one, I'm setting some of the things that I like to set for the SSHD daemon, right? One of them is I like to turn off root logins so that you cannot connect to root, because that's the most common target that people have when they try to break into your system. They'll just be like, oh, does root work? Let's try root. And then they'll just attack root all day long. And if you have root logins turned off, they can try it all they want. And even if they guess root's password, it still ain't going to work. So I like to turn that off. And then, of course, I'd have to log in as my user and use sudo to get escalated privileges, which is really best practice anyway. The next one is password authentication. Some people like password authentication over SSH. Some people don't. Personally, I like to turn it off and use key authentication instead. And you'll notice that at the end of the playbook here, at the end of the list, I have public key authentication, yes, because if that's the default, it's on by default. However, password authentication, I believe, last time I checked, is also on by default. If I'm turning that off, I want to be sure public key authentication is also turned on, because if for some reason that's turned off and then I turn off password authentication, I've just locked myself out of the machine. So let's not do that. So that's why I like to be explicit and say, turn on the public key authentication, turn off the password authentication. And then permit empty passwords. This was just one that I came across as I was setting up this role, which sounded like a good idea. So I threw that in there too. Okay, so so we're ready to run this. Again, I have this set up just to run on localhost because running it on the other machines, whatever. So let's close that out of here and then let's just run it. Nope, that's not the word I want. Okay, so what this is going to do is it's going to run through it. And then the way this gets created on the machine that it's running against, which of course in this case is localhost, is it just makes a drop-in file. Called 00 Ansible system role. And if I look right inside of there, you'll see literally the things that I put in the role get dumped into there. So basically, the way I was reading about this particular module or this particular system role, it just takes the config setting from the SSHD config, and that's the thing that you define within the system role as that variable. And then it basically puts them into here for you. Now, there may be exceptions there, so you'll definitely want to check the docs if you're trying to do something advanced with your SSHD configuration. But now that should be in place. If I were to try to connect as root, it shouldn't let me. If I were going to try to connect with a password instead of an SSH key, it shouldn't let me. And there we go. All right, so the other one is the system logging. And of course, this is a RHEL system that's running systemd and the system journal. Although there's also, as we've talked about on previous episodes, there's also sort of a stub there of our syslog for compatibility. There's another system role that I believe allows you to control our syslog. This is specifically for the system journal. And in this one, I think I might have set that host wrong because I didn't test this one. Did I test this one? Maybe I didn't. We could be going off script here. I may have gotten distracted. So we're going to set the host back to localhost just to be sure. What this one's doing is it's setting just kind of some options here that I think might be common for folks that are running in a systemd journal setup. One of them is there was a release of RHEL where you had to tell it that you wanted to save the system journal in a file. It wasn't just ephemeral, or is that just, I forget exactly where the context was there. But you can set up the system journal so that the log is basically stored non-persistently, right? So you'd have to use journalctl to see what's coming out of it. And for a lot of cases, that's just not okay. I need a stored log file for, audit purposes or for maybe archival purposes, right? So what this would do is it tells it to set persistent storage, turns on persistent storage. This tells it to compress that thing so it doesn't take up a huge amount of disk space, because text might seem like it doesn't take up a lot of space, but it sure takes a lot less space when you compress it. System, let's see here. Set the total log size to a gig. Again, configurable. You can set that as big or as small as you want. Keep at least X number of disk space free on the logging target. Seemed like a good idea, so I threw that in there as well. Retention, of course, is important. If you have retention policies that say we keep X number of days, you want to actually set that so that you're keeping that number, because if you miss it by even a day, you could be in trouble. And there's some other, sort of settings in here for things like that journalctl rate limit that you see. If you've ever seen that, where a bunch of the same log message comes in a short amount of time, it will collapse that. It'll say, 30 entries match this in the past X number of seconds. That's what this is getting set here, I believe. And then, of course, the burst setting for the rate limit as well. Okay, so again, let's go. Oop, I did change it. I forgot I changed that to localhost. Let's go ahead and run that. Okay, and yeah, I want to say I did forget to test this one. So we're going to be learning on the fly here. Okay, so it ran. That's a good start. It did complete, so that's good. But what I didn't do is go verify where we're going to see the changes at. So let's go to Etsy. I forget where the config is. Is it in systemd? Where's the journal D configuration, Scott? You remember?
I'm an rsyslog user. I don't know what you're talking about.
Is it in here? I don't know. Oh, there it is.
I mean, it looks like it
is. Journal D conf D, except JS is not a command. We'll just go into the.
Maybe it is, but only for JavaScript.
Look at that. 99 Linux system roles journald.conf. See that? We didn't even have to fumble around for too long. And sure enough, there's the settings, right? So there we go. My journal is now going to work in the way that I've just said. Sorry, Shantanu. That would have been very helpful, except the stream is delayed by a couple seconds. So you were close to right, though. Okay. All right. So were there any questions I missed? Were you watching chat? Or it looks like you answered a few things.
We talked a little about AAP. So Axel VQ9UW asked about logging so that people could see that automation had been done on their boxes. And so he was talking about local playbook execution, but also AEP, which is Ansible Automation Platform. And one of the big things with Ansible Automation Platform is all the reporting of what automation gets run on which thing, and whether it's successfully completed or not, and all kinds of auditing.
And I do believe there are log entries on the target systems, although you have to basically look through like standard system logs to see, oh, look, the automation user connected. Oh, look, the user did these things. And I think even if I recall, tlog will record that it logged in and it did stuff, although the stuff that it did may not be obvious because it's running it. I did actually test this once. I had a customer ask me and I tried it out. It's not as straightforward, but I would recommend that if you need that level of logging for, audit purposes or whatever, that you probably don't want to be manually automating the way we're showing today. You probably want something like automation platform.
Yeah. And there is like some settings in your Ansible CFG that tells it where to log. There's probably some differential between the controller, right, where you're running the Ansible playbooks from versus the client systems that are having the automation run against them.
Yeah.
So, but yeah, I would say Ansible automation platform is the more enterprisey way of keeping track of those things.
Right. Right.
All right. So the last demo, and Nate, I had to re-provision my ephemeral box because we took too long and it blew itself up.
Oh
So
no.
let's see if it works. The last thing I've got is crypto policies. All right. So we're going to go in and look at my now much smaller central playbook because we reset it.
Because it all got blown away on you.
That's right. Stupid ephemeral machines. So we add our new role, RHEL System Roles Crypto Policies.
All right. So what Scott's about to work with is
added.
Oh, go ahead.
Oh, now that we've got the role added, we can start adding the variables. But go ahead and tell us what we're doing here, Nate, with crypto policies.
Yep. So if you're unfamiliar with the system-wide crypto policy tooling that's built into RHEL, what this will let you do is you can set kind of the low bar, whatever the lowest bar is for cryptography on your system. And what's supposed to happen is every service that the system-wide crypto policy is able to configure, it'll reconfigure for whatever sort of level of crypto policies you want applied. So we've talked a lot about post-quantum crypto with the release of RHEL 10. The system-wide crypto policy is kind of how you implement that. You say like, set me to the PQC, or I forget what the policy is called, and then everything it can change, and all the policy or all of the crypto algorithms that we know about that are being slated for post-quantum ready, then they'll get applied to your system. But that's not the only way you do this. There's also, or not the only way, it's not the only thing you can do with it. You could set kind of like the whole, there's different levels for the various cryptography for things like legacy connections. If you're still connecting to older systems, or older systems need to connect to you, you can see that Scott is setting it to future here. So it looks like you're ready to go. So go ahead.
Yeah. So essentially, it's all of the applications that use cryptography on RHEL are compiled against libraries that use cryptographic policies. So as long as your application is not providing its own cryptographic libraries, it's using system ones, we can then set at a system level what is or is not permitted in terms of ciphers and algorithms. So like, do you want DES3 to be used on your systems? Like, is that okay? Crypto policies help you, even though the algorithm may exist, it'll actually keep applications from consuming that algorithm. And the place where we really saw the need for this was Heartbleed, where all of a sudden we realized that there are all these old OpenSSL algorithms that people were using, old like encryption ciphers for web stuff that we just like kept in the configs forever because we wanted to maintain backward compatibility. And then all of a sudden we were like, oh, that was really stupid. We should not do that. So crypto policies basically are, should SSH use, I don't even know, more modern algorithms, and we're going to cut off older algorithms for it to use when encrypting its SSH connection traffic. So we've grouped these together, and the default is called default, but we also have legacy, which is a bunch of older ones. So even though they're installed on the machine, we wouldn't use them with default. But if you toggle the crypto policy to legacy, all of a sudden you can use these older algorithms. And then future, which is what I'm about to set now, actually is only stronger algorithms. So for example, let's say we were creating GPG keys. No, let's say we're creating SSL keys. And by default, we create an SSL key that's like, 2048 bits in length, if I remember correctly. And under the future policy, that's not allowed. Your SSL certificates and encryption algorithms need to use at least 3072 length keys. And so even though you're using the same algorithm, the strength of the certificates and stuff also can be adjusted by changing your crypto policy. All right. So I'm going to be much more finicky about what I allow cryptography algorithms to use. I may even require stronger cryptography by using the future setting.
Right.
Policies reload. So we're going to go ahead and reload the policy on the system when I go through and make this configuration change. Crypto policies reboot okay. So we have a whole bunch of applications like Apache, web browsers, all kinds of stuff that have been already loaded into memory. They're using the old cryptography policy because it's already been loaded in memory. So a reboot is really the only way that you can refresh all of your applications to utilize the new cryptography policy. Okay,
Right.
However, if I say cryptography policies reboot okay, true, Nate, what's going to happen when I apply this playbook?
It's going to reboot the machine that you run.
That may not be my intention.
Now,
I'm going to go ahead and take that one out.
A better way might be, if you know what services are going to have to be reloaded, you could call those out specifically and reload them using other mechanisms within Ansible. But I guess the only way to be sure is to reboot the machine, right?
Yeah, and we actually have a couple of crypto policy labs if you're interested in them on lab.redhat.com. And one of the things we do is we go to future, your Apache web server breaks because it's using the not expansive enough bit length on its keys. So we change the SSL certs on it, and then we restart Apache so that it gets the updated stuff that it needs, and then everything's fine.
Right.
All right.
And we have one on customizing crypto policies too, I think, don't we?
Yes.
I thought
where you can actually select what algorithms you allow.
Yep. So if you're like, I really want future except for these two things, then you can go in. It shows you how to make those exceptions.
All right. So right there. System policy is set to future. Right. And then I could go back and change it to the oh so aptly named default. Right, so it's changing the configuration and then changing any services that need to be hopped. But yeah, so that was the last one. And so Nate, also, I mentioned labs. Did you know that we have a system roles lab that does things like change kernel tunables and set time servers and enable session recording?
Why, no, Scott, I had no idea. Tell me where I can find this lab.
Yeah, so if you go to lab.redhat.com, under the operate section, there is a thing that talks about building a standard operating environment with system roles. And it kind of gives you a brief introduction of how one could use system roles to kind of default manage their systems. All right,
but you might only get an hour to do it, just like Scott had on his lab.
Yes, but I mean, most of the labs there are like 20 minutes tops.
Yeah, I know.
So there we go. We've gone back to default. Default.
So comfortable.
All right. So I think that runs us off the end for system roles. Oh, there was a question about Python and Ansible.
Yeah, maybe you have a better answer than I did. I was a little iffy on my answer in the chat.
Does Ansible rely on System Python? Ansible core relies on System Python. So yes. And that's why, like in RHEL 8, we shipped both Python 2 and 3 was because system roles and the Ansible that came with RHEL relied on Python 2. That is
Right.
no longer the case. It relies on Python 3, so like we're good to go there.
Now
But the default Ansible relies on system Python.
the system that you are automating against, though, like the system you're controlling, that doesn't have a requirement to have a newer Python, right? So like the
No,
target system, that
No.
is. No, that's what I thought. That's what I thought.
Yeah. So yeah, we're good there. It's more so there's the nodes, and then the system that you're running from is the controller, if I remember
There you go.
the wordliness correctly.
Right.
The controller uses system Python. The nodes can just be whatever their default is.
Right. Right. And the only additional information that I threw into my answer was that if you are at Ansible Automation Platform, it uses these execution environments that are like a container. So it's not quite as hard linked to the system Python as it might have been, or as it is with Ansible Core. So,
all right. So next week we'll be doing another Into the Terminal. Don't know what it is yet.
We will do stuff.
We'll figure it out
next week. However, the week after we're going to have to skip because we're both on airplanes, I think.
Yeah, we have a like big internal Red Hat conference that we have to go to. And so not next week, but the week after, we will be skipping a week because Nate and I will be face-to-facing with other Red Hatters. Maybe some high fives will be exchanged.
Yeah.
I don't know. Definitely some hugs happen. Especially when I see Uzoma. We always get a nice hug out of Uzoma, who's a great hugger, by the way.
He's a good hugger, definitely.
Yeah.
And a good guy.
So join us next week for another Into the Terminal. To be determined, but it will be there. And then we'll go from there. Thanks for tuning in, everyone.
Awesome.
If you have questions or comments, don't forget to throw them in the comments if you're a deferred viewer, and we will monitor and get back to you. All right.
Yeah.
Thanks, everybody. Have a great one.
Everybody have a great one.